Take a look at these two photos of outer space. What do you see? They're basically identical, but not quite. Now look a different way, in sequence. Here you see something different, something moving. That dot is a newly discovered world. It's closer than we ever thought possible. And the trick we use to find it could rewrite the story of our cosmic neighborhood. Today, scientists have our solar system pretty well mapped out. We know about the 8 planets, Pluto, moons, asteroids, comets, and until recently, we thought we had a handle on our solar neighborhood too. There's the Alpha Centauri system about 4 light-years away, and Barnard's star, a red dwarf a little farther out. Astronomers made these discoveries more than 100 years ago. But today, some new work is totally upending our view of the neighborhood. It involves a space telescope, an army of volunteers, and a scientist on a very specific mission.
My name is Jackie Faraday, and I'm an astrophysicist at the American Museum of Natural History.
Jackie has spent 15 years searching our solar neighborhood for new neighbors. She's focused on mysterious worlds known as brown dwarfs, balls of gas that are too big to be planets, but too small to be stars.
Now, they're often called failed stars, but I really dislike the word failure in the title because I just feel like it's kind of demeaning to the brown dwarf, like it needs to be a star, it doesn't care. And so oftentimes I call them overexcited planets.
Brown dwarfs would be stars if they were more massive, but without enough hydrogen, they don't achieve nuclear fusion. They emit lots of infrared energy, but very little visible light. So for a long time, they were hidden to astronomers. But that all changed in the 90s.
Infrared technology and infrared telescopes started to come online in earnest. And when that happens, you start to see these sky surveys that are able to produce the wavelengths where you can actually see the brown dwarfs.
The first brown dwarfs were ID'd around 1995, and since then, the field has exploded. Today, the astronomy community is awash in imagery that could harbor nearby brown dwarfs. Actually, finding them is another story, but there's an old technique called the blink method that works wonders. The basic idea is that all stars are in motion relative to us. Most are so far away that they move imperceptibly. But objects in our solar neighborhood, those are close enough that we can actually catch their movement, if we're patient enough. Here are 4 images taken with various telescopes over a span of 32 years. If you flip or blink through them, you see that not everything is staying put.
Objects of interest that are in the nearby vicinity, they will move, they will jump against the background of stars.
That is Lumen 16, a pair of brown dwarfs that's only 6.5 light-years from Earth. It was discovered using the blink method in 2013, and it's now the 3rd closest known system to ours.
We had not changed that list of objects in the top 5 in a century. It shouldn't happen. We should not be finding objects all of a sudden that are spitting distance away from us that we've been missing all this time.
The blink method isn't new. Clyde Tombaugh used it to discover Pluto back in 1930, and it's been used to discover moons, asteroids, and dwarf planets. But paired with new infrared imagery, it's slowly bringing our neighborhood into focus. A little too slowly, really. A few years back, Jackie found herself staring down millions of images that could contain new discoveries. It was daunting.
I am spending hours of my time every week blinking images in like my spare time, and I can't, it's frustrating. It's taking too much time and I'll never get through all of it.
The images are noisy and blurry, and each one needed real attention. It was far too much for any team to handle. Unless that team were hundreds of thousands of people.
And so thus sprung our citizen science project.
At the beginning, my girlfriends didn't understand why I was looking for just a bunch of moving pixels for hours.
Starting in 2017, Jackie and her team invited the entire internet to go hunting for brown dwarfs. Their system is dead simple. Users log into a website and meet their first astronomy flipbook.
The images come in a sequence of 4, and it will flip. Those images flip through time. So it shows you what this point in space looked like in this year, and then a little bit after, and then a little after, and then a little after.
So you'll kind of see blue and orange dots typically that are everywhere.
It looks like you're staring at colorful television static.
It can be kind of annoying at first if you don't quite know what you're looking for.
But if you're lucky, you'll catch a mover.
When you finally find something moving, it's a bit of an adrenaline rush.
Faster moving objects actually do blink across the screen. Slower ones might just twinkle.
They're basically these little tiny like white dots that will flash when you play our flip books.
Either way, you can mark your anomaly and alert the community.
I think I found something, and everyone else kind of is like, yeah, that's one. It's like, oh, yes, I'm good. I found something.
The most promising leads end up on Jackie's radar. Her team can then book telescope time to look more closely. For you, citizen scientist, it's back to blinking.
It's like in a world, it's like a treasure hunt in your couch. It's really something that keeps you hooked.
Since Backyard Worlds launched, volunteers have been on a tear.
They've discovered hundreds of nearby objects.
Some were a novel kind of compact frozen world.
Prior to Backyard Worlds, there was only 24 of them known. They added 5 new ones.
Others had surprising new atmospheres.
Really strange looking objects.
And still others were hidden siblings of known objects.
I had certainly studied the brown dwarf in the system a lot in previous work, and never did I guess that it had a little cold companion with it.
All in, hundreds of thousands of users have found more than 1,500 new objects. Volunteers like Dan and Guillaume have gotten credits in academic papers for their discoveries. There's still more to find. Jackie thinks the effort could reveal a brown dwarf even closer than Alpha Centauri, a new next-door neighbor. There's even a chance we could find the Bigfoot of our solar system, Planet 9.
There is an object that's theorized to exist beyond Pluto that is massive, that it could be causing some objects in the outer solar system to be bumped around a bit. And it's an exciting prospect. Now, does it exist? I don't know. I'm happy that we have citizens that are very interested in trying to find it. If it's real, if it's there, and maybe it is.
As successful as the blink method is, it has competition. Artificial intelligence has been huge for astronomers who need to sift through tons of imagery, including Jackie.
The human eye is beautiful at picking out things. It's just slow because we have to go image by image. And so human eye wins in some ways, but AI wins in speed. So I use both.
One limitation of AI is that it needs to train using examples of things that it's looking for. So if that thing is brand new, human brains have the edge.
You are the trained algorithm at that point.
That said, astronomy is facing a tidal wave of data. In a couple years, astronomers will begin imaging the entire night sky of the southern hemisphere, twice a week.
There is no way we are looking through all of the data in the classic ways in the coming future. Like, it's over.
For now, Jackie will take all the help she can get, from human volunteers to algorithms. The humans are more enthusiastic about it.
You spend countless hours poring through images and designing custom algorithms and services, and you get something great. It's super exciting to see that all of this work that we put in has an impact.
You can say to yourself, yeah, it's something I saw, and I'm the first human being in the whole history of mankind to see it. It's a great feeling.
Thank you to Lexis for their support. Be sure to check out the new Lexis IS by going to lexis.com/IS. Their campaign is about going all in on your passion and getting a greater reward, which is why they sponsored this series on researchers and innovators. They don't influence our editorial, but they do help make videos like this viable. So thanks again to them, and thank you for watching.